Here's an example of a problem in our Chapter 6 Normal Distribution section. And I want to show you how we can do this both using Microsoft Excel for those of us who are using that tool, as well as using the TI-84 for those of us who have that calculator. So it says, suppose that the duration of a particular type of criminal trial is known to be normally distributed with a mean of 21 days. So I'm going to put that in here for my mean, and a standard deviation of 6 days. So I'm going to put that in there for my standard deviation. Let X be the number of days for a randomly selected trial. Round all answers to 4 decimal places where possible. So question A is just asking you to recognize that it's normally distributed because we were told it was, and that its mean is equal to 21 and its standard deviation is equal to 6. So that's just a normal distribution notation that we're learning to use. Capital N out in front and then 2 numbers in the parentheses separated by commas, the first being the mean, the second being the standard deviation. But B is asking us to find a probability. And the probability we're being asked to calculate is that it will last, that it lasted at least 18 days. So I'm a very visual person. So I went and used one of my favorite applets and I drew this normal distribution. I centered it at 21 days and I counted out by 6. So 21 plus 6, 27 plus 6, 33 plus 6, and so on. And then below the mean, 21 minus 6, and then that minus 6, and then that minus 6. So I can picture that 18 is somewhere between one standard somewhere between, one standard deviation below the mean and the mean itself. So it has a z-score that's between -1 and 0. So when you use your normal command in the Excel spreadsheet, you must always give it several pieces of information. Now in Robert's videos, he shows you how to use the formulas tab, but you can also use just an equal sign and begin to type the command. So equals always has to be entered first whenever you are wanting Excel to calculate something. So equals, and then I'm going to just start to type norm. And you've seen from his video that norm.dist will find for you the area under the normal curve within a particular interval. So I'm going to double click on that. And what's nice in Excel is that it tells you exactly what you've got to give it. Well, X is the boundary line in our shaded region. And so that boundary line is we're looking for the probability that it is at least 18 days. So X is 18, comma. The mean, of course, is 21. I can just type it here, or I'm just going to click on the cell, comma. The standard deviation is 6, which again, I can just type 6 there, or just click on the cell where I entered the 6, comma. And we're always going to be saying yes or true to this cumulative because cumulative means within a region. And actually cumulative means at or below. So this command is going to tell us the proportion of days that are at 18 or below. We'll talk about what we'll do with that to get 18 or above. So we just say true with regards to cumulative, okay? And we hit enter. Now the area below 18 days in this normal distribution is equivalent to 0.3085. But we want the area above because it said lasted at least 18 days. So the area under a normal curve is 1. So if you know the area below 18 days is 0.3085, then the area above 18 days will be 1 minus 0.3085. So I'm just going to type equals 1 minus and click on that cell. And that makes more sense. We can see that that blue region is actually more than 50%. And so we did get a probability that is greater than 50%. When using the TI-84 to calculate our answer in B, we have to use what's called the normal cumulative distribution function command. And this one is a little different than Excel in that you can give lower and upper. It doesn't automatically do proportion below, and then you have to do 1 minus if you want proportion above. So in our blue shaded region, the lower value is clearly the boundary line that was given to us, 18, comma, the upper value, you just use a really big number like 99999, comma, the mean is 21, comma, and the standard deviation is 6. And it will return the very same value. So I took a picture of what I did on my graphing calculator, and this is what I see. I get the very same 0.6914. So it doesn't matter if you're using Excel or if you're using the graphing calculator, you will get the very same answer. Okay? Now what's different with C is that now we're finding the area between two values. So let's start with how we go about doing this in Microsoft Excel. What you're going to have to do in Microsoft Excel is you're going to have to find the area below the lower of the two and the area below the upper of the two and subtract those areas. So we're going to use that same command, equals norm.dist. Double click. The lower of the two in C is 22, comma, mean, comma, standard deviation, comma, yes, we want cumulative. But now we need to subtract the area below the upper of the two values. So minus, and then norm.dist again, double click. The upper is 25, comma, mean, comma, standard deviation, comma, yes, I want cumulative. I want area below. So then what it will do is it will take the area below the smaller and the area below the upper, and it'll take the bigger area minus the smaller area. And we get, ooh, I did something wrong. Oh, I have it backwards. You got to take bigger area minus smaller. Well, I'm glad I made that mistake because that might be something you do. You cannot have a negative proportion or a negative probability. You should be taking the area of the bigger, 25, minus the area of the smaller, 22. Silly me. And then just hit enter. And so we find that that area between is 0.1813. If we're using the TI-84 graphing calculator, we go back to that same normal CDF command, but this time our lower boundary is the smaller of the two and our upper boundary is the larger of the two. But the mean is still 21 and the standard deviation is still 6. So we get the same answer. So again, it doesn't matter which tool you're using, you're going to get the same probability. So finally, in D, it's saying 64% of all of these types of trials are completed within how many days? They're telling us that there's some number of days in this normal distribution at which 64% of all of the trials are completed within that many days or less. So once again, I went and drew a picture with my applet, and I know that if the percentage below this value is more than 50%, we must be above the mean, because the mean is the 50th percentile. It's got 50% below it, okay? In a normal distribution, I should say. So we can see that it's going to be something that is somewhere between 21 and 27 days. The question is, how many days is it exactly? Well, this involves using the opposite command in Excel as well as the opposite command on our calculator. That opposite command is the norm.inverse command. So again, it's going to calculate something, so I've got to start with an equals. Norm dot, and you notice inverse is the second option. Double click. Once again, Excel always tells you exactly what you need to enter. What's the probability? And this is always the probability below, which in our case is 64%, which when you change it to a decimal, which you must, is 0.64. And then our mean, 21, and our standard deviation, 6. You don't have to tell it true. It knows that with this command, we're talking about the cumulative area below is equal to 0.64. And we find that that's equivalent to 23.1508 days, which seems logical given our picture. On the TI-84, we have to go back to that same menu, second vars, but inverse norm is option 3. And then we'll give the following. The area below, so the command is very similar to what it is in Excel, 0.64. The mean, 21, and the standard deviation, 6. And we find that that produces the very same number of days, 23.1508. Let me know if you have any questions.